Welcome back to lecture number 7 on types of ejector refrigeration system, part 2. Previous lecture we have discussed the two types of ejector refrigeration system. So this lecture we will discuss the remaining two types of ejector refrigeration system. So this is the third type, that is refrigeration system with integrated ejector. In this particular type, the refrigeration system is integrated with the ejector refrigeration system. And here the ejector works on or whatever the primary fluid that is flowing to the ejector. So that primary fluid is generated on the waste energy of the condenser. So the waste heat is utilized here. And because of that, the COP improvement is around 9 to 10% it is observed for R22 refrigerant. And this particular configuration is especially used to improve the performance of uh, vapor compression system because vapor compression system is clustered to the ejector refrigeration system. So slightly complicated, but we'll try to understand the working principle of the same. So again, this is vapor compression cycle, and it is cascade with the ejector refrigeration system. And in order to increase the mass flow rate through the evaporator also, in addition to the compressor, the booster is also used. So we'll discuss the working principle. We start from point number 1. So that is the compressor inlet. So first we discuss the vapor compression cycle. So 1 to 2 is the compression in the compressor. So 2 to 3 is 2 to 3 dash is the desuperating, and during this desuperating it also generates the vapor in the generator, which is used as a primary fluid. Then 3 dash to 3, 3 dash to 3 it's a condensation process at 50 degrees Celsius. Then 3 to 4 is the expansion. So 3 to 4 is the expansion, and 4 to 1. So 4 to 1 is the evaporation process. So this is vapor compression cycle, and the ejector refrigeration system is clustered to this vapor compression cycle. So again, at the same from the evaporator, part of refrigerant is used in vapor compression cycle, and part of refrigerant is extracted for ejector refrigeration system. So it is extracted at point number 6. So point number 1. So 1 to 2, 1 to 7 in this case. 1 to 7 is uh, compression in the booster. So booster is used. Booster is slightly a lower version of compressor, similar to compressor, but it may be a aerodynamic compressors. So boosters can be used. It just assists the compressor. So its compression ratio is not as good as the compressor, uh, general conventional compressor. So it's slightly less. So 1 to 7 is the compression. Then it enters into the secondary. So it's slightly the pressure is reduced, and at 8, that is the mixing point, 8 dash, because after mixing that 8 dash, so 8 dash to 8, again the pressure rise in the diffuser section of the ejector. So then again, and the same because the condenser A and condenser B working on same temperatures. So the 8 to 9, that is condensation in condenser B, as both are working, even though these are the separate condensers, but they are working on same pressure. So we can see only on same pressure. So that is 8 to 9. Then at point 9, the stream divides into 2. So one line it goes to the uh, expansion valve. So that is 9 to 9 to 10. Sorry, 9 point and 10 point is there. So it's coincide. So 10 to 14 is the expansion in the expansion valve, and again 14 to 1, that is in the evaporation process. The second line it goes to the pump. So from 11 it pumps. So pressure rise happens, that is 11 to 12 in the during the pumping process, and 12 to 13 that is actually the boiling process. So evaporation in the generator. So that is with the help of this waste heat recovery. So the compressor heat is utilized to generate the primary fluid. So 12 to 13. 12 to 13 is the generation. Then from 13 it enters into the primary nozzle. So when it enters into the primary nozzle, it expands up to the booster pressure. So 13 to this particular point, that it expands, and this point and 7 at mixing point is 0.8 dash. So this is a basic thermodynamic cycle of refrigeration system with integrated ejector. So here, main role of ejector system is to improve the performance of refrigeration system. So simultaneously, it uses the waste heat of a refrigeration system, and based on that waste heat, it works. So generally, this system is suitable for high discharge temperature refrigerants because the heat required in the generator is more. So the high discharge temperature refrigerants like 410A, 7C, these are the refrigerants where the discharge temperature is close to 120, 130 degrees Celsius. So such a high temperature we can utilize to generate the primary fluid. And this waste heat is utilized, and on the basis of this waste heat, the ejector system works. So this is how the refrigeration system with integrated ejector system works. So these are some theoretical notes, points we can say this, because this is integrated with vapor compression cycle. It works on waste heat recovery, and it also uses booster, and because of the booster, mass flow rate increases, and consequently capacity, uh, refilling capacity and COP increases. The fourth combination, that is a combined power and ejector refrigeration system. So this is quite a conventional system in most of the steam power plant. The excess steam is available, so that steam is also utilized to generate the cooling capacity with help of ejector. So this system is only suitable if there is existing steam power plant. So it works on both vapor compression cycle as well as the Rankine cycle. So both it works because steam power plant works on Rankine cycle, and an ejector system works on vapor compression cycle. So it works on that. And here, some part of steam is utilized, is extracted from the turbine, and with the help of the ejector, the cooling capacity is developed. So this cooling, generally, the cooling of the control panel, which is situated near the steam power plant, there we can utilize this ejector refrigeration system. It's quite economical solution because steam is already available at higher rate, and the excess steam is available, so we can utilize this excess steam to produce cooling capacity. So we'll again discuss here uh, how the cycle works with the help of pH diagram. So again, in this case, there are pressures, that is evaporating pressure, uh, then ejector pressure, and boiler pressure. So these are the three pressure lines. So in this case, as this is a normal steam power plant, so generally the state of refrigerant at the entry of the turbine is not saturated because the power plants which are used for generation of electricity, they are high pressure boilers. The state is essentially a superheated state. So 9 point is on the superheated state. So 9 point is that. So 9 to 1 is the so when the expansion starts. So at the intermediate level, the steam is extracted at 1. So steam is extracted at 1, and it further expands in ejector up to 2. So from 1 to 2, it further expands up to 2. Then 2 and 7 mixes. So mixing point is 3. So mixing point is 3. So from 3, it enters into the diffuser section where the diffuser part is pressure rise happens. So from pressure, then it enters into the condenser. So it condenses. So 4 to 5 is the condensation process. So again at point 5, it divides into two lines. One line goes to the evaporator, other line goes to the boiler through expansion device and pump respectively. So 5 to 6 is the expansion in expansion valve. Then 6 to 7 is the evaporation process. Then 7 and 2 mixes. The mixing point is 4. So similarly, the second line, it goes to the uh, boiler through pump. So the pump, the pressure rise happens from 5 to 8, and 8 to 9, that is actually a boiling process. So this completes the cycle. Uh, so this is generally associated with steam power plant. and mainly used in sugar industries where the ample steam is available in most of the cases. So in that case, this system can be used. So it gives power out this particular system. It is a combined system. It gives power output as well as the cooling capacity. This is some theoretical part. You can refer the notes, especially while writing the short notes can be asked. And at the end of this particular topic, you should be able to explain the refrigeration system, integrated ejector system, uh, their construction working, how it improves the COP of the system. And the second one that is combined power and ejector refrigeration system. Again, applications and its working principle that we can discuss. So with this, we have completed unit number 1. As far as the unit number 1 is concerned, we have discussed almost 12 cycles. So 7 cycles of transcritical cycle system and 5 cycles of ejector efficiency system. So mainly we have discussed 2 advanced vapor compression systems. Uh, their basic cycles, their types, their improvement in COPs, their construction working. So generally, this exam point of view, this 7 plus 5, that 12 circuits you have to memorize based on their schematic diagram, their pH diagram, their processes used, important features. So most of the things are given in the notes. You can refer the notes as well. And also one numerical part that is on the simple ejector refrigeration system, where the numerical can be solved using pH diagram as well as property table. So this is what this is all about the unit number 1. Uh, uh, I have completed each and every point of unit number 1, exam point of view. So if you are solving numericals, you can do numericals. Still, it is alternative to 5 circuits. Still, it is recommended you should prepare all 7 plus 5, 12 circuits as well as the numerical part. So the next lecture, we are going to start the unit number 2, that is thermal design of components of refrigeration and air conditioning systems. So basic 5 components we are going to discuss, their characteristic curves, their design aspects, and some types in cooling tower also we are going to discuss. So hope you understood this particular topic thoroughly. If still not, you can ask me the queries during the Moodle session, during the interactive session, or also you can rewatch these videos to understand again and again. But it is recommended to prepare your own notes with the help of on the so it will be helpful for you for examination as well. Thank you very much.